Hello, good morning to all. Yesterday we have seen the topologies, basic topology. What is it? It is one of the layout, how we are what connecting our devices. That layout we are termed as the topology. We have seen the mesh, star, and ring topology. Today we will see the bus topology. Okay. So as you can see in the diagram, that in this diagram there is only one cable or only one line and their different devices are connected. Okay. So that is that. Bus topology is a network type in which every computer or a node is connected to a single cable. This topology is mostly used in WAN and wireless network. So see, there is only one single cable. So obviously it will transmit the data from one end to other in a single direction. That is important. There is no bidirectional arrow here. So our communication or transmission of data is only in single direction. It is one of the main feature of this bus topology. Different nodes are there and we are going to transmit the data in the single direction. Okay. So what will be the advantages? First, if the number of devices are increased, then what will happen? What will be the feature? If I want to add more devices, more nodes, then what will be the requirement? Imagine if I want to again add two more or three nodes. So just through this cable, we can directly add more devices. Okay. So number of cables required is only one, which is actually it is called as a backbone cable, and these are called as the drop lines. Okay, for the devices. So one cable is sufficient, and the different drop lines we can use for connecting the number of devices. So obviously through this our cost or money will be saved. These are the advantages. You can write down advantages if you know the basic functions of this topology. Then next is the problem. So what will be the problem? Installation and configuration are difficult when the number of devices are increased. Here I have written the short. Okay, you have to explain in the exam why difficult. When number of devices increased, then number of cables, drop lines are also increased. Okay, the cost of cables is high as bulk wiring is required, hence suitable for less number of devices. Each topology, including the mesh, is suitable for less number of devices. Okay. Next is the cost of maintenance is high because we have to provide the security for each node. Okay. And maintenance means if the single cable is there and if it fails, then we should avoid the crashing of the system. So which type of data, how data is transferred, there must be monitoring in between the transmission. So it is about the bus topology. Okay. So if question on this topology, you have to draw this figure. Then we have to write down the main points, advantages and disadvantages. Advantages are easy. You can write your own. For the problems or disadvantages, you can refer this or you can read your study material. Okay. Next topology. is the tree topology. So what is that? The structure from the diagram, it is clear that what a tree topology is a sort of structure, means this is a structure in which each node is related to the others in a hierarchy. Okay, actually its structure similar to tree, so it is called as what? Tree topology, means the pattern of connection resembles a tree. Okay, tree, then there are branches like this, so this topology is termed as the tree topology. So imagine or see the situation where this tree topology can be arranged. So it can be arranged in the databases and the workstations, okay, in the corporate networks. Here again, one central node is there and the different nodes or components are connected to this node. So every node in this topology is connected to one of the upper level, okay, in the hierarchy level. So this is the tree topology. So what will be the advantages here? Where we can use this tree topology? Advantages and disadvantages. Any topology, what we have to do? We have to see the advantages and disadvantages. So see what will be the advantages. Scalability. When the number of nodes we have to increase, scalability is in the form of what? When we have to increase the number of elements or devices, it is easy. Okay, we can form a connection here and we can add the different nodes. So that is the advantages, that scalability can be increased or number of nodes can be increased easily. Next, if one of the node fails, okay, if the leaf nodes are failed, then the other nodes are not affected. Okay, and it is highly secure. Okay, because these two nodes are guided by or controlled by this one. Again, this is controlled by this, so it is the security level is high, or it is this topology is more reliable than the different topology. Next, what is the problem? Failure. It's like the centralized. So failure in the central hub or the central node will bring the entire network down. If this centralized node fails, then the entire network will be stopped. Next, more cabling is required when as compared to bus topology. It is obvious, bus has only one single. Here we have to increase the number of nodes, so we have to increase the cables. So this is the problem with this topology. Tree topologies are used in the examples. It is used in the WAN, wide area network. Okay. So clear this tree topology, we will move to next, that is the cellular topology. So what is that cellular topology? You can see in the diagram, we are using this cellular topology in day to day. Okay, that is in the wireless media or in the mobile computing, we are using this cellular topology. What is that? The cellular topology divides the area being serviced into cells. Okay, or we can see that in the wireless media, each point transmits in a certain geographical area that is called as cell. Okay, each cell represents a portion of the total network area, and devices that are in the cell communicate through a central hub, and these hubs, centralized hubs in different cells are interconnected. This is one of the example. This similar structure we can copy here, and this centralized hub and this centralized hub can be interconnected with the wire. Okay, so like if you remember the mobile computing diagram, then there are different cells and they are connected through that centralized hub, and the transmission is through the wireless. Okay, the wireless media is used for what? Communication here. So this is what our regular mobile communication, where we are using the wireless technology. Means what? We are dividing the portion of the total network area as a one single cell. Okay, and in that cell there is one central hub which take care of what? Communication through the different devices, and these hubs are interconnected to the different cell. This, imagine this is one of the cell. The same structure we can use here for the another cell in the another geographical location, and we can connect this hub with that to form the cellular topology. So what will be the problem? Advantage: wireless communication. Okay, no cabling is required in the devices. Only we have to what? Connect the centralized hub. Next, what will the problem? Simple problem. If there is centralized hub, then centralized station or any centralized node, we have to write the same problem for each topology. That what? When a hub fails, all devices serviced by the hub lose services or the communication. That is the cellular hub topology problem or disadvantage. Okay, so I will request you to form one difference table for each topologies, starting with the from the mesh to cellular. You have to what? Draw the diagram. You have to write somewhat 2 or 3 points about that topologies, advantages and disadvantages. So remember this topology in this terminology like differences, then you can remember or you can write all the questions which will related to this topologies. Okay, I hope you are getting it. We will move forward with the networking model. So here we have covered our what? All the topology. Now next is a networking model or network model. So basically what is model? I hope you have learned the model, database model concept in the database management system. So what is that database model? It is the what? Layout, different models. I think you have learned like PR diagram, network model, object oriented model. So what is a model? So model is a what? a way to organize a system's functions and features to define its structural design. I'm sure you have learned the entity relationship model also. So that is the structure layout of that entities tables. Now we will see what is the networking model. So network model, what it will be defined, it reflects a design or architecture to what? To perform communication between different systems. Okay. Here system means the anything, desktop, laptop, node, anything. We have to what? Communicate with the different system. So we have to reflect a design or architecture, and that architecture is called as what? The network model. And mostly the network model consists of the layer, or we can term it as a stack, and each layer of a model represents a specific functionality. Okay, we will see the different layers, but stacks or the layer means what? It has some specific functions which we have to carry out for what? Communication purpose or for transferring data from one system to other. Okay, so this is what about the networking model. We will see the next is what? OSI, Open System Interconnection Model. I hope you know about this model. So what is that? The Open System Interconnection Model describes 7 layers that computer systems use to communicate over a network. What is the basic purpose of our networking model? We have to communicate with the different system. Okay, so it is a reference model that describes how information from a software application in one computer, okay, in one computer moves through a physical medium to the software application in another computer. We will see the detail, but this is just the introduction. What it was, what first standard model for network communication, and it is invented in what? 1980s. This model is divided into 7 layers to represent network architecture. Each layer performs its own set of tasks. Okay, means assignment or specific functionality is given to each layer so that the communication or transformation or the responsibility is given for successful network transmission. Okay, are you getting this? OSI reference model, network model, it represents what? How we are transmitting the information through the set of layers to the other device through the set of layers. Okay, so this transmission is what governed by these 7 layers, and it was invented in the 1980s. And for that responsibility is distributed so that the functioning must be carried out properly. Okay, so we will see the different layers. See, at the top there is what? Application layer, then the presentation layer, then the session layer. Next you can see the transport layer, network layer, and the data link layer and the physical layer. Here what we are seeing, this is the software or upper layers, application, presentation. See, the colors are same. Then heart of OSI, that is the transport layer. Then hardware lower layers, that is network, data link, and the physical layer. And its functions is given here. What this application layer is doing, what are the responsibilities for the application layer. Then next for the presentation layer. So we have to see the responsibility for each layer. Now see, what is application? Application software means the specialized software. Okay. Now, when we have to send the messages over the network, there are different protocols. Okay. So the protocols used for this application layer are the what HTTP. I think you all know about the HTTP protocol, FTP, Telnet, then DNS protocol. Okay, these are the example protocols which are used for the application layer. This is the upper layer in the OSI reference model. User is directly communicating with this application layer. Okay, and application layer means what the user interfaces. Okay, and user interfaces behind that there is this application layer which allows access to network resources through the protocols like HTTP. FTP stands for the file transfer protocol, Telnet, and the DNS. Next layer is the presentation layer. So what is the function? It function is what? Translation, encryption, and compression of the data. Translation, encryption, and compression. And the example protocols are what? SSL, TLS. Okay, you have to remember it and you have to find out the working of this SSL and TLS for the extra information. Okay, for the exam purpose, you can just write the example protocols for the presentation layer is what? SSL and TLS. So we will what? 1 minute. Okay, after this I will write down the example protocol on the whiteboard. Next is the session layer. So session layer is what? What is the sorry, session layer responsibility is if we are using the regular what? Okay, you are using the mailboxes, then there are sessions given by that Gmail or that email providers. Okay, so that session is governed by this session layer. See, application layer means what? Everything we can see on our computer, monitor, or the mobile. Means the application software we are what? Using in front of our, okay, like your web browsers. Next is the presentation. Presentation means what? It is the code language. For example, the code language of a web page like the HTML, JavaScript. So it is not useful for the different user, but it is useful for the presentation layer. Okay. Next is the session layer. Before we have to see any web page, any website, we need to create a session with that web servers. Okay, session means that in short we can say it is the meeting or the scheduled meeting, or just remember that is the session. We have to create a session with that particular web server, and the session layer connects applications to the connects application with the web server. Okay, here main work of this session is what we have to establish a session with the web server. Okay, we have to manage them and access them and close them once our work is done. Simultaneously, we can create the many session at the same time with the different tabs. Okay, we are using the different tabs for creating the session with different web servers. Means this API, sockets, WinSock, these are what the session layer. Next is the heart of the OSI model, that is the transport layer, layer 4, which is the very important. Okay, it is responsible for making a TCP connection to the web server. TCP stands for what? Transport Control Protocol. This is reliable form of transport which creates a three-way handshake with the web servers. Okay, what is three-way handshake? This is not in our syllabus, but it provides the reliable processes for message and error delivery. Okay, means it guarantees that delivery of the TCP segments will done or the error message will be passed. Okay, segments means what? Packets. Okay, so it is the main heart of this OSI reference model, which provides reliability that your packets or segments are what? Transported, or otherwise there will be the error message will be given to the receiver. This is about the transport layer. Next three layers are the hardware or the lower layers, which carries the different functions. Okay, so next is the network layer. What is the function? It moves packets from source to destination to provide inter networking. Okay, so after TCP job is finished, it will pass the packets to the down to the network layer. Okay, where IP will work. IP stands for what? Internet Protocol. Now this IP uses the IP address to identify the location where the information must be routed. Okay, so the protocol used here is what? The IP protocol. Now the IP in this IP version has the 4 header. Header means the different fields which explains like what? The address, sender, receiver, like this. This information is contained in the header. Okay, so network layer moves packets from source to destination. Next layer is the data link layer. It organizes bits into frames and provides hop-to-hop delivery. Okay, the data link layer. What is the role of the data link layer? It gets the data, okay, and then that data or bits we have to frame it, okay. Means what? We have to format that data into the suitable frames, and then we have to forward this to the next layer. Last layer is that the physical layer. What is the role? Transmits bits over a medium, provides mechanical and electrical specification like coaxial cable, wireless, hubs, etc. So the last layer is the we have to go from this. So this is the first layer. We have what started from the upside. So the first layer is the physical layer, which actually deals with what? Physical medium transformation. Okay, means this coaxial cable, wireless hubs are actually the physical medium through which the bits are transferred. Okay, so this is about the OSI reference model. I hope you have understand it. So shall I repeat once again? We can see the division that this OSI reference model is divided into, basically it is divided into two, but we can see the division. Heart we can skip upper layer and the lower layer, and heart is in between this. And this three is the responsibility of the host. Okay, and last three is the responsibility of the network. So the upper layer deals with the application related issues, and they are implemented only in the software. Next, or the lower layers are deal with the data transport issues. The data link layer and the physical layer are implemented in hardware and software. The physical layer is the lowest layer of the OSI model and is closest to the physical medium. That is what? Coaxial cable, wireless media, etc. So this is about the OSI reference model. You have to write down the functions of each layers. Okay, so how this data is actually sent, and receiver, how the data is received by the receiver through this physical layer. So next we will see the working, that this is what your application, this is means the user interface is there, this is also user interface is there. When we have to transmit the data is actually passing through this, and this is the actual physical medium. Means this may be the LAN connection, or maybe any wire through which these devices are connected, and the data is the transmitted through these 7 layers, and then this physical data link network transport session, presentation and application. Then that transmitted data we can see in the user interface. Okay, so actually up to this the data link layer bits are there, then that bits are framed, and that framing of bits in the 0101 format, then it is transported through again that is decoded, and then we can see the actual message or transmitted data in the receiver's screen. So if the question, mostly the question come on this transmission 7 layers, you have to remember all these layers, and we have to remember the functionality of these OSI layers and how the data is being passed in between the two devices. So this is actually our human computer interaction layer, where the data is what present here, and that data will be seen here. Then next is the presentation layer. It ensures that what data is in usable format and data encryption is occurred here. Next is the session layer. What it will be maintain? It maintain connection. Okay, if the connection is not with this application, then data will not be transferred. So session layer is responsible for what? Maintaining the connection, and is responsible for controlling ports and session. Next is the transport layer, which what uses transmission protocols, which includes TCP and UDP, okay, for transmission of data. Next is the network layer. Network layer decides which physical path we have to take, okay. So we have to, actually this layer determines the physical path. Then the data link layer, it defines the format of the data on the network. And next is the physical layer, which transmits the raw bit stream over the physical medium. Okay, so this is about the TCP IP. So can you write down the different protocols which are used for each layer on your notebook or on your notes for remembering? So application layer, which protocol? HTTP. Okay, so you have to write in the format of this layer. Here you can also draw one more figure for the example protocol. I will write down. Okay, I have to, I think this, we have to pause this, and then we have to text. So for this application layer, we can write the protocols here, like what? HTTP, then FTP. Okay, DNS, Telnet, you can write down. Next is what? For the presentation layer. Presentation layer, the example protocols are what? SSL and TLS. Okay. Next, for the session layer. Session layer, the protocols are PPTP, point to point, and one more protocol, NetBIOS is there. Okay. For the transport layer, the protocol is what? TCP and UDP. Okay. Next, for the network layer, we have to use the protocol. Most used full protocol is what? IP. And again, there are some different. IPsec is there. Again, there are ARP protocol is there. Next, for the data link layer, the protocols are what? I think this will be visible in your presentation or recording. I don't know. We will try. For the data link layer, PPP, ATM, and the Ethernet. And for the physical layer, we have to use the protocol. Again, we have to use the Ethernet, then the USB. Actually, we are using it Bluetooth. Okay, so this type of protocols are for the Ethernet, USB, Bluetooth for the physical layer. So we will see the next. So this is about the protocol, example protocol for the various layers. So I will resume share. Okay, sorry, new share. So we are there. So here I have written down the protocols. Next, we will see the TCP IP reference. Okay, this is not going with. So this is permanent here. Okay, I will stop here and I will again make a small video for the next 2 slides as this protocols writing is seen on my screen. So thank you.